right. Welcome everyone. We got some folks filtering in here. We're gonna get started in just a couple minutes. But while we're getting set up here, look to the bottom, use the chat feature and let us know that number one, you can hear us. And number two, who you are. We wanna get a sense of who's in the room. So let us know if you can. All right, thanks, Gregory. You can hear us. Welcome. Yeah. Introduce yourself in the chat so we can kind of get a sense of who's here. All right. So like I said, we're going to get started pretty soon here. Thanks, JD. I'm going to do just, if you've never been to a mini AMA, just give you a little heads up on what to expect. AMA is short for Ask Me Anything. So mini AMA is a series that we started in about October, and we have subject matter experts on and answer your questions in real time on a variety of different topics. This week, we're really excited to be talking about 3D printing. We have Dan and Mike here who are going to go through, it's going to be really cool where we're going to talk, have the Q&A, but we're also going to have a workshop part of it where you can kind of see Dan in action on this. So if you're not familiar, Mini AMA is put on by Minnestar. We're the nonprofit community organization, and we are built to nurture and engage those interested in technology through meaningful connection. So we put on events like these, and we also do Mini Bar, which if you're not familiar, it's the nation's largest and longest running unconference, tech unconference. Mini demos, which are like geek show and tells. We have 7 presenters get 7 minutes to do a live demo of working Minnesota made tech. We have one of those coming up in August 6th. So it'll be virtual. And we also have a limited drive-in experience at the Minnesota State Fair. So very socially distance friendly. We're really pumped about that one too. So that's a little bit about us. Like I said, we have a really awesome conversation happening today. Mike is going to be our moderator, so I'm actually going to kick it over to him and we will get started.
Thank you, Maria. Welcome everyone to today's AMA. Of course, the topic today will be on 3D printing, and hopefully we will be able to answer all the questions you might have on the topic. So before I start though, I would like to thank all the folks over at Minnestar for all they do to help support and grow the Twin Cities technology community. And I'd also like to thank Maria specifically for doing the hard work of putting this event together today. So thank you. As your moderator, again, my name is Mike Schmidt, and I'll just take a few minutes to just give a little bit of my background. I started my career in technology as a software developer and became an entrepreneur when I founded a company called Nerdery about almost 20 years ago now. Today, Nerdery is a digital business consulting organization that focuses on product and service development. I also helped found Prime Digital Academy. Prime Academy is an accelerated learning school that is designed to help people get into technology careers at a fast rate. So personally, I think of myself really as a lifelong learner and a serial hobbyist. So I enjoy learning new things, picking them up, sort of understanding how they work, and then I have a habit of moving on to the next thing. So, but 3D printing is something that has become interesting to me just in the very recent few months. I've had a few things that I wanted to make and little problems that I wanted to solve, and there was no market out there for me to be able to do that. So I had to just take it upon myself to do that, and 3D printing was a way to do that. And anyway, so it's generated some interest from me in learning more about it. So like you, I'm like most of you, I assume, I'm relatively new and have questions about this. So I look forward to sort of picking Dan's brain on 3D printing and learning more. So before we start, I guess I wanted to share a little bit about what to expect on today's event. Dan is going to take the first 20 to 30 minutes and give a presentation on sort of the basics of 3D printing, which I expect will probably answer many of the base questions that many of you might have. The remainder of the time today we'll use to answer your questions. And so in order to ask those questions, please enter them, into the chat. And as we go along, if questions come to mind while Dan is presenting, by all means, just plug them in and we'll get to them as we can when he's done. And we'll go to about 1 o'clock. I think we will have probably a hard stop around then. So I guess I'll start by introducing our guest speaker and expert, Dan Grigsby. Dan and I've had the pleasure of being able to get to know Dan over the past couple of years, and he and I have become good friends. Dan is a native Minnesotan. He started his career, and his whole career has really been focused on technology, but he's had the opportunity to have a wide range of different experiences throughout his career, including being an entrepreneur and starting companies, along with working, in leadership roles in large enterprise organizations. So I think kind of going back just to give a little history on him, he founded Drivetrain in 2010, which was a small mobile development group here in the Twin Cities. He exited that and became the CTO of Wildflower. Wildflower is an education reform spinoff out of MIT Media Labs. And then most recently, he was the senior VP of product development at a Silicon Valley startup called MoveSoft. What I've learned about Dan over the past few months is that Dan too is a lifelong learner, and he has a passion for bringing new ideas to life and to reality. And that passion has given him the opportunity to become an expert in a lot of the tools that makers use to experiment and innovate. And to that effect, he has become an expert in the 3D printing world. So with that, I would like to welcome Dan, and so welcome.
Thanks, Mike. You're a class act. I just wanted to start by seconding what you said about Minnestar in general and Maria specifically. Maria's been in the role of executive director for, I think it's coming up on 3 years, and the organization has really flourished under her leadership, and having that dedicated attention to it benefits us all. So she's someone we should all feel grateful for. What I intend to do has been kind of described so far. It's walk you through what it's like to do 3D printing. I'm going to follow the minibar ethos, no slides. Do have a few images, so maybe I'm walking the line a little bit, but I want this to be show to go along with my tell. I always like to start with why. And so the why behind 3D printing is going to be different for different people. I will give you mine, and I'll give you some thoughts around it, and then we'll spend most of the time actually hands-on looking at things. So the highest level why that I can think of why you'd want to do 3D printing is because it feels good. It feels good to build. It feels good to create. It's neat to have a little bit of Genesis on your desktop. So you can go in all sorts of different directions on, hey, Maria, would you mind enabling screen sharing for me? So you can go lots of different directions on this. And so, 1 second, please. There we go. So a philosophical way that I sometimes think about this, I actually cribbed from Gandhi. So when Gandhi was resisting sort of the British, he had this idea that putting the tools into the hands of people to be able to create the things that made up their life was a powerful thing. And so he created this cultural connection with looming. And so in prison, he learned how to create thread and then weave that thread. And so it had this huge political idea. It created this feeling of autonomy. And so there is a real feeling of autonomy that you get when you do these things. So I was watching, of all things, Man in the High Castle, and there was this concept right in the middle of it that I thought was really neat. So the setup on this is that there's alternate history where the Germans and the Japanese won World War II. The Japanese are occupying San Francisco, and they love Americana, so they want cowboys and Indian stuff. no room in that culture for any kind of move to Native American. It's very much the sort of caricatures. But what happens is the Japanese aristocrats find a sort of feeling. They call it wu. It's actually a Chinese word where when they look at a thing, they feel like there's some sort of soul to it or something like that. And so I get this myself with high quality kitchen knives. And so I have spent hours and hours and hours at a forge in my garage pounding steel to get to the point where I'm starting to have some approximation of a kitchen knife. And one day I think it'll be beautiful. The thing that's neat about 3D printing is that it shortens the path. And so a lot of us are software people, and a lot of us take the idea that you want to be able to be agile. You want to have the idea and then see it out in front of you. And so with 3D printing, you can do that. And so I think it's a pretty fun thing to pick up. It makes me feel like I felt when I was very young and learned to code. I had that sense of awe. Now, it must be said that I learned to code during the TRS-80 era, and I came with some rough edges. And there are some of the same, or at least similar, frustrations that come with 3D printing. And when we get into the sort of the details of this, maybe we'll cover those. But let's move there from the why to the what. I want to talk a little bit about what you can make. And so here I'm going to move my camera around a bit here. So for me, I like, see if I can aim this right. I like making machines. And so I'm building a CNC. It's another machine for making other things. And I needed to be able to take all of these components and put them together in a frame that makes sense to me. And so I created these components here to be able to attach this, which will drive this as a gantry. And it allowed me to create things to hang on the sides here to be able to put the bearings to be able to create the motion that makes the machine go. And so for me, it's a tool. It's a tool for making, in a lot of cases, other tools. With my kids, it's for making Baby Groot, the Millennium Falcon, and a Star Destroyer. And so anything you can kind of think of, you can print and you can put in front of you. And I'll show you in a minute or two the steps that go through that. And that extends also to, and I'll go back to sharing my screen now, things that have societal use. I've got a good friend, Nicole. Nicole's a nurse. Nicole lived in Paradise, that town in Chicago that burned to the ground. She's had a bad couple of years. Well, I can make her life a little bit less worrisome, a little bit more secure by printing her 3D printing her personal protective gear. And so if you look at the top here, this is a printed piece, and then this is a bottom printed piece, and they just put some plastic in between them. And I sent her and her colleagues 24 of these things. So let's narrow the discussion a little bit. So we're going to talk about 3D printing, but we're going to talk about it through the lens of the home user. So I'm going to leave out biological. I'm going to leave out printing metal. I'm going to leave out industrial, and I'm going to talk about what you can do from home. And that's the part of this that I think speaks to me the most. And so we'll start with workflow a little bit. And so workflow, I think of as a framing. I think it's useful to do the sort of 7 habits thing. Start with the end in mind. So we're going to talk about what the end thing is, what you give to the printer to do its job, and then we'll begin at the beginning. So starting with the end in mind. Ultimately, what you do is you give your printer code. It's called G code. It is a sort of standard that is used widely in lots of different kinds of machines. But basically, what it does is it makes your printer move belts and motors and screws and to heat up a bed and to heat up an endpoint to be able to melt plastic to precisely put it down in layers on a flat surface. And so it's kind of interesting, actually. The idea for 3D printing came from somebody with a glue gun. So Minnesota native from the sort of, I think it's the CTO of Stratasys, came up with the idea for 3D printing while dealing with the stringy stuff that comes out of a glue gun. And after a lot of work, this is something that's now accessible to all of us. So if our end goal is to give the printer G code that fits its particular dialect, we have to begin with a shape. And so shapes you can either download or build yourself. And so there is a website out in the web, I guess it's redundant, called Thingiverse. Thingiverse has tens of thousands of shapes that people have put up and shared with you. So this is their homepage. And so I looked earlier for something that I thought would be illustrative, and I chose this knobs collection. So Thingiverse obviously has the sort of things you'd come to expect. You can search for different shapes and so on, and then you can click through their collections. This is a series of a bunch of different knobs. I can download the files and get them as a zip file, open the zip file up, and then ultimately there's a series of STL files. So STL is a shorthand for stereolithography. It's a bunch of triangles that make up a shape. It makes up a solid. And so you can feed that, you can feed, I just lost my train of thought here. Oh, that's really interesting. Hold on a second. Just had a speaker notes crash, but I have a backup, so bear with me here. All right, so here we are. Okay, so quick recap. Went to Thingiverse, found something that I wanted to print, downloaded it, unzipped it, and now I've got this file. Now, when I double click on the file, it brings it into a tool called a slicer. So what a slicer does is it takes a solid object and it says, okay, we're going to slice this into little pieces. What a 3D printer does is not actually 3D printing. It's sometimes called 2.5 dimensions, because what it does is it takes a solid object and it puts it down as layers. So you make a little layer, then you put another layer on top of it, and another layer, and another layer, and so on. So let me demonstrate that. So I picked a particular knob handle here, and I can set up the printer to print it very high quality and strong, or to print it very quickly as a draft. I can define how precise I want it to be. And so there's a bunch of trade-offs. Drafts are fast and ugly, but you get the shape in your hands really quickly. Smaller layer sizes will give you more details, but obviously it makes it take longer, because instead of taking this and printing it in 100 slices, you're printing it in 1,000 slices, for example. So just to kind of keep this rolling along, I'll show you what it would look like if I printed it with a layer height of 1/3 of a millimeter using PLA, which is a kind of plastic. We'll talk about those a bit later. So I click slice now. So what it's done now is it's taken that image and it's broken it down into these different layers. And so what you can see is that it's going to put down a bottom layer, and then on top of that layer, it'll just keep adding and adding and adding. And over the course of putting down layer upon layer of plastic, ultimately you get this finished shape. In this case, it's pretty quick. It would only take 5 minutes for me to print. It would use 0.2 of a meter of plastic. And that's actually one of the things that was kind of surprising to me. It ends up being really inexpensive. Some of these tools will even have things that'll be built in, but this would probably cost a few cents to build or to print. And ultimately, even when I'm building the parts for these machines and they get very big, the cost is quite affordable. So that was a pleasant surprise. Okay, so we've just gone through a sort of microcosm. We found an existing shape. We downloaded it, we put it through the slicer. I would export it, I'd put it into my 3D printer. It would heat up, and in probably a little bit more than 10 minutes by the time everything's said and done, I'd have this thing in my hands. That's the workflow in microcosm. But that was a workflow that started out with someone else's shape. Most of the things that are interesting are when you create your own shapes. For example, the time Mike and I worked together on 3D printing was to build a custom boat bracket to hold his fishing rods in his fishing boat. And so I'd like to walk you through some of the ways you make your own shapes. So most people probably use, hold on, please. Most people use a CAD program called Fusion 360. It is from AutoCAD. It's fairly simple to use. If you ever used SketchUp, you're already on your way there. The idea of taking these shapes and being able to extrude them, pull them around, and so on. I personally don't use Fusion 360. I'm a bit nerdier than that, so I thought I'd show you some of the tools that I use. So the first tool I used was something called Openscat. And so the S in SCAD is software. So it's an open software-based CAD program. And for the programmers in the audience, this might feel like a natural way to get started, because it takes a C-like programming language and lets you use it to create different shapes. So for example, let's just make this a little simpler here. Let me take this out. I can say, make a cube that's 10 by 10 by 10, and it will make a cube that's 10 by 10 by 10. Now that's not a very interesting shape, and so I want to add another shape to it. And so what I'm going to do is I'm going to move 5 millimeters on the x-axis, and I'm going to put in a cylinder whose radius is 3 and whose height is 5. And when I do that, it updates the drawing. And so I've built reasonably complicated things. My first crack at building my own 3D printer, I built all of the parts here in Openscat. So it's not a great tool for art objects. And so, for example, doing this Millennium Falcon would have been an impossibility. But when it comes to mechanical objects, it's a pretty short path. Where I do most of my work these days, though, is in an open source project called FreeCAD. So FreeCAD is really neat. It's got a learning curve, and unfortunately, I think they kind of expect people to have a set of experiences that maybe the typical programmer type of person won't. But underlying all of this is a Python data structure. So even though everything is graphically designed, you can always sort of quote unquote shell out to Python and do really interesting things. But let me just kind of give you a quick sense of what's behind it. So I'm working on a 3D printer project, and I'm working on a laser cutter project. I have this belief that the next tool after the 3D printer is the laser cutter. And I actually think that it is likely to be bigger and more broadly used than 3D printers. We'll talk about that a little bit at the end, I think. And so I'm designing a laser cutter, and I'm printing a lot of the parts that go with it. So it'll have those aluminum extrusions and the mechanical things and so on. And I need to stitch them all together. So this is what is wrong with this? There we go. This is a bracket that'll hold a stepper motor. And it's put together by drawing a shape. So I can, for example, create this shape here. And then when you extrude that shape, you get something that looks like this. Now that you got that shape, you want to be able to put holes into it. So I need to be able to, this will be a place that a motor sticks out and it needs to be screwed in. I need to be able to mount it to the aluminum extrusion. So it needs to have places for screws. And I've been able to draw all of this. And it's neat because it's a parametric thing. And what I mean by that is it's not just drawing, but it is flexible. So I can say, you know what? I think instead of using extrusions that are 25 millimeters, I'm going to go up to ones that are 50 millimeters. When I do that, I should be able to redraw it. And of course, there's some issue. Phil, the Prince of Heck, always damages demos. So in any case, in theory, although not apparently in this demo, I would be able to make changes to a set of variables, and then they would automatically roll through and change the part there. Okay, so I'm known as a fast talker, so I'm just going to take a breath and say that I think we should talk about how you choose a printer and what kind of plastics and other things you need to get started. And so for that, I'm going to just talk. So I'm going to stop sharing here for a second. Actually, scratch that. I'm going to have a few things to talk about. Okay, so when I sat down to write this part of the presentation, originally I was going to show you 3 different printers. I was going to say they represented a low, a medium, and a high level of investment to be able to get into printing. Ultimately, I changed my mind. So let me tell you a little story about how I came to this. So I came to this, as you can see here, on November 20th of 2016. So I've been doing this coming up on 4 years. And it started by buying this printer. This is called the Monoprice Maker Select 3D Printer version 2, blah, 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 blah. It is made by a company called Wanhao, and they export them from China to Monoprice and to a bunch of other folks. This may be the, by number, world's most popular printer. It's cheap, and it's cheap in both senses. It's inexpensive and it's cheap. And so I had this experience with this printer that was both amazing and frustrating. I learned an incredible amount because out of the box it didn't work that great. And I had to do all these modifications, and I worked on it, and I worked on it, and I worked on it. And I worked on it until a year ago. And a year ago, I got tired of working on it. And so I bought a Prusa. So the difference between the Monoprice at $329 and the Prusa that I bought is significant. It's almost twice the cost. That said, this machine is bulletproof. It came out of the box. It just works. And so there is one path that says you take the cheap printer and try to make it better, and you learn a ton about it. That's everything that I know about 3D printing, and I shouldn't say that, everything I know about 3D printers. The base skill set that I built up to be able to design this laser cutter that I'm working on, all of that came from trying to get reliable prints out of the cheap printer that I bought. When I finally decided that I didn't want to be focusing on the printer, but I wanted to focus on what I was printing, I spent, by the time it was all done, about $1,000 on this Prusa printer, and it has just been spectacular. And so originally I was going to say, well, there's a couple of choices. There's this cheap one, there's this expensive one, and then I was going to look at the middle one. Well, the middle one is the Prusa Mini. It has a lot of the same things that the cheap one does, except that, I'm sorry, it has a lot of things that the expensive, even there I'm saying the terms wrong. It has most of the capabilities of the bigger standard Prusa in a smaller form factor. It's a smaller form factor at a price that is basically the same as the cheap one. And so when you look at a printer, you really have one must-have, and that is the bed must be heated. So this place that the plastic gets put down needs to be heated. It keeps the plastic in a state when you put the next layers down and layers on top of it and so on, you get adhesion. If you didn't have a heated print bed, they would peel up, it would curl up and warp. Jamie Fingelstad, the former board member at Minnestar, wanted to learn about 3D printing, and he was disappointed when he got himself a printer that didn't have a 3D printing bed, because anything above about 1/4 inch he just couldn't print. What you get in the sort of middle ground here of this is the heated print bed and then this little probe here. The challenge a lot of people will have when they start printing is you've got this plane and you're putting plastic down on it. Well, it's a heated plane because, like I said, it's a heated bed, and machines need adjustment. And so you can adjust these beds basically, and if you have it slightly off, when it tries to put down the plastic, it'll squish down on part of it, it'll be doing the right thing, and then it'll just sort of sit above it on the rest of it. And so what's a nice thing about these printers is they have a probe that can tell how far above the heated bed is. And so if I was buying a first printer right now, I'd buy the Prusa Mini. It's $379, and it is, oh look, they're back ordered. So maybe you wouldn't buy this one right now. But in any case, and it's a kit, but it's kind of half the fun. People who tend to be drawn to this tend to like to build things, and so putting together the kit is a neat sort of middle ground for trading price for quality. All right, last thing to talk about, and this I'm gonna share, is plastics. When you print, you have different choices. So most people learn to print on what's called PLA. PLA is a corn-based plastic. And so here I am wearing the ally of Black Lives Matter. I'm sort of, let's call it like it is. I'm a liberal. And so the idea of printing a lot of things in plastic and having that end up in a landfill isn't pleasing to me. So PLA is a very easy to work with plastic that is biodegradable in large sort of municipal compost facilities. And so PLA is a good choice, very easy to work with. It's very strong. It's not flexible though. So if you have something that's going to be flexing a lot, it may actually break. When you need something that's either going to be able to flex and also that can handle some heat. So PLA, because it's corn-based, because it can break down in a compost, obviously the heat causes it to get softer. And so a good friend of mine has a daughter who's diabetic. He's created this thing called the Riley Link. It is a little mini computer that stitches together her continuous glucose monitor and her insulin pump. And for a case for that, when he tried to print it in PLA, her body heat would make it kind of soft. So when you have those cases, there's two other alternatives. One is called ABS. ABS is it's kind of a flex. It's a thing that people who make 3D printing their personality always print in, because it is the most like injection molded plastic. So if you want something that looks like it came from manufacturing, ABS is the choice, but it comes with a cost. The cost is that it's finicky. It's harder, it has a weird smell, but that's probably the least of it. It is environmentally sensitive, and what I mean by that is, like, if you have it in a drafty room, it doesn't work. So the sort of nice middle ground, if you want a printer printed plastic and you're not planning to biodegrade it, is something called Petg. It is just about as strong as ABS. It is just about as easy to print as PLA. And in fact, when Prusa prints their own parts for their printer, so when you look at my printer here, so all of these parts are printed by Prusa for their own printer. They're printing those in Petg, and so that's what I use when I want durability. It's basically what I use. It's what I use when I'm going to keep something. When I'm playing around, I print in PLA so that I can compost it. Okay, so I think from the sort of prepared remarks material, from the prepared materials or prepared remarks, I should just talk briefly about sort of things that are alternatives or other machines that people might consider. So 3D printing is obviously what this talk has been about. 3D printing, people tend to then go off and buy some other machines. So one is a CNC router. The thing I showed you on the floor there is a very elaborate mechanical device that I've built to take a router and move it around. And so 3D printing is putting down materials. This one is removing materials. The attraction to it is that it can work on aluminum. For a ton of money, it'll work on steel, but for anyone who's watching this, except the person who's at General Mills, they probably have real CNCs. But for the CNC router, working on plastics or aluminums or woods, it's a good choice. That said, it has a need to be mechanically strong. If you look at this thing is incredibly strong. I could actually show you the engineering diagrams, but I think it could probably lift my wife's minivan. It could support the weight of it. That is sort of antithetical to a mass consumer product. And so when you look at the consumer grade CNC routers, they tend not to be that great because it's hard to get a sort of priced, it's hard to get the stiffness and the mechanical strength down in a reliable way without having a lot of price. The other thing that makes CNCs a little difficult is you kind of need to be a skilled operator because you need to say, okay, not only is this the ultimate shape, but you need to break down how the tool is going to work. And so there's a lot of heavy lifting. And so I think the more interesting one, I mentioned this before, is laser cutters. So laser cutters all around are easier. And what I mean by that is laser cutters work in 2D. So if you use Inkscape or any popular 2D sketching program, you can take those things and you can cut or you can etch using a laser cutter. So you don't need to use CAD. There's no tool paths to deal with. When you look at makerspaces, Makerspace's most popular machines are laser cutters. The reason, by the way, that they're so popular in a makerspace is that with a big asterisk next to it, they're expensive. What I mean by that is if you want a good laser cutter for what's available in the market right now, you're looking at $3,000 to $5,000. There are, of course, cheap ones. And so much like there's a cheap 3D printer, you can get $350, $400, they're called K40s. They're a generic type of laser cutter that is imported from China. I can tell you that they're put together trying to optimize price. And so they basically overdrive an underpowered tube. You don't get a lot of shelf life. They're potentially dangerous. There's a lot of caveats. The purpose of my project, the thing that I'm working on, this design, is to create an open hardware laser cutter option. So anyone can build it. I'll sell them, but you can also build it yourself. And then, the aha moment I had, and I don't often kind of refer to Elon Musk, but Musk looked at what does it cost in just fuel to put a rocket into space? Because the price of a rocket should be mostly the fuel. And what he found is that there's this huge gap. Well, I did the same thing. I looked at what are the fundamental components that go into a good laser cutter. It's not $3,000 to $5,000 worth of components. And so what that tells me is that Glowforge and the folks at the sort of top end of the market have created a gap. There's these cheap ones, the expensive ones. I believe there's a space in the middle for good quality components without the cost of the Glowforge. And so Maria asked me earlier, what am I doing? So I'm currently laid off. I have the benefit of having had some successes, and so I'm spending my summer building an open hardware design. And so I think laser cutters are where it goes from here. All right, I'm going to take a breath. I've seen things popping up as I talked in terms of questions. So Mike, if you would please fire when ready.
Yeah, Dan, so would you start by just sharing with the group what you wish you knew before you started 3D printing? What are the gotchas and things that people should consider?
Sure, yeah. So I opened with the idea that this feels like programming when I was, in the late 70s. I'm an old guy now, where you had all of this power, but periodically things would go horribly wrong, whether it would be magic smoke from the TRS-80 or it would just freeze and so on. So what I wish I would have known at the beginning was to value my time higher. So I bought this crappy 3D printer and thought I could put effort towards it and learned a lot. But I have a friend who describes it as more of a lifestyle. Like you adopt the 3D printing lifestyle. So what I wish I would have known, I think people have this notion that you're going to be able to create art objects like this and they're going to be functional. My kids like these, but they sit on a shelf. They're not, when they're art objects, they are not generally very strong. You kind of make a choice. You say, I want, mechanically solid or art object. I would have liked to have known, frankly, I didn't buy a 3D printer for a long time because I was worried about getting locked into somebody's ecosystem. What I've learned since then is that there's really very little lock-in. People tried to do sort of DRM-based, so people would try to sell printers for cheap and then make the filament, the spools, DRM'd. All of those folks have sort of fallen by the wayside. And so I think the thing to know is that the risk is pretty low. At worst, you're out the money you paid for the printer. But now that the Prusa Mini is so inexpensive, I wish I would have just gone right to a better printer.
Thank you. 3D printer manufacturers market in terms of speed and layer thickness. Is this really what people should be looking for when they're evaluating a printer and on the market looking for one?
Yeah, so it's a good question. If I was submitting questions, it was a question I would have asked at the beginning of my experience. So Monoprice, the company that sells the printer that I bought originally, has a more expensive version of the printer, and they market it as being faster and having more resolution. And it doesn't, full stop. It has the same set of stepper motors. So the stepper motors are the things that make the motion happen. And those stepper motors have the same both speed and resolution. And so I think when most people get a 3D printer, they start off and they try to do, and they succeed, the tiniest little layers. They make something it's beautiful. So like as an example, I listened to a podcast ages ago about an ancestor of humans, a baby being pulled up by a giant eagle and eaten. Really scary. And they found the skull, and I wanted to see to scale what this kid looked like, and so I printed the skull. And because I wanted to be able to see the talon marks, I printed it really, really fine. So everyone will do a very, very high quality print, but most of the time what people end up using is a little slower and a little thicker, because the thickness doesn't reduce the aesthetics, and the slower gives you a better result. And so in a short answer, no, those things aren't as important as the manufacturers would have you believe.
What are some of the differences between a good 3D printer and a bad one? Specifically, there are some questions out here asking about some specific name brands such as FlashForge and SnapMaker. But do you have an opinion on these particular brands? And what's your thoughts on what makes a good one and what makes a bad one?
Sure. So I don't have encyclopedic knowledge of the different manufacturers. So I every year Make Magazine, and even I think in its currently construed form, they're continuing to do this. They release a 3D printer issue every year, and you can buy back issues. And so for $3, $4, or $5, you can get a digital copy of it. So those folks do a very, very thorough analysis. And for every printer, they'll sort of give a strengths and a weaknesses, who it's good for, who it's not good for. At this point, though, frankly, it feels like Prusa is just the best choice all around. So I don't know the two brands that were mentioned. For a while, it was almost cliche that the one thing on Kickstarter that had like the most attention and also the worst ship rates were 3D printers. And so I just buy the Prusa. The Ultimaker is very good as well. But it's 2-3 times the price, and I don't think it gets you more. So I wish I could say specifically about those two brands. I don't know. If you want to evaluate them, though, look at the print head. So even Prusa doesn't make their own print head. So the thing that the melted plastic comes out of is a very critical component. And there are actually, let's just cut this and make it simpler. There's a guy on YouTube, Tom's 3D. He has an entire series that can let you pick any dimension of this. But ultimately, you're talking about build size, you're talking about materials that it can print, and you're talking about the head and the sensors. And so those are the things to look for.
Can you, would you take a moment and I guess just talk about a couple of the different techniques that are out there right now for 3D printing? I think generally, you know, what you are describing here is what's known as FDM. Can you speak a little bit about the SLA?
The lasers.
Yeah, the lasers. And would you just talk a little bit about what the differences are, what the pros and cons of each are, why someone might choose one of those types over the other, and what your experience, I guess, is with SLA printers? Sure.
Okay. So SLA printers are very neat. They're neat because they do provide a higher level of resolution. So I'm not an expert on these. Every time, and I'll talk about why I'm not an expert in a second, because I think there's sort of the meta story behind that. But the difference is that they use a laser to activate resin. So imagine a bath full of resin, and you're using a laser, and where the laser touches, it becomes solid. And so you can build up a series of layers. And so they're very popular, for example, in jewelry design. Because of the sort of solidifying fluid and having more control over the fluid, you can do very, very small layer sizes. So my understanding is, and it's been a year or two since I've looked though, is that the resins don't have the mechanical strength. And so a very common case for using the resin printers is to create something that you're going to then cast. And so using it as so if you're doing casting where you take a form, you pack sand around it, you put some channels in it, you pour molten metal into it, the metal melts the stuff out, and you're left with the shape. That's what I mean there. The other thing that until recently was true is that they're very expensive. And so what's been interesting is that people have said, well, maybe instead of using a laser, we can use an LCD. So you've got the vat, and then instead of having a laser, they just literally have a panel. So right, imagine I'm taking my iPad here, and it is the floor of a vat of this stuff, and the light sensitivity of it makes it solid. And so the same manufacturer that Wanhao has a printer of that type. It's not gotten very good reviews. So for me, and I can't claim to have perfect insight in this, I haven't yet seen a printer at a price point that is in that family that's made me move off of it, move off of this and get one of those.
Can you talk a little bit about safety? Are there resins that people are using right now in printers that are create an unsafe environment while they're printing? So where ventilation is needed. What concerns or what should people be thinking in terms of safety and fumes that are generated from the process? Sure.
All right. So I'm not a doctor, and so I'm speaking from my own experience and just from my grandfather was a machinist, and my other grandfather was a chemist. And so I'm used to being in workshops and labs where you get a little bit of the smell of the things that are around you. And so that said, I brought my printer from my workshop to my office. And the reason is that with the PLA, it smells sweet. Some people have a childhood association. It smells like something from their childhood. I don't quite get that, but because it's corn-based and there's sugars in it, it actually smells sweet. So I don't know the chemistry exactly, but I don't think that there's an issue there. The other two, ABS and PLA, these are things that in consumer products are safe for consumption. So PETG and ABS are used in consumer products. So when you get a bottle of soda, That's PETG. So the ultimate end state is not toxic. I don't know about so I don't know if you were to have a bunch of the molecules of the fumes that it would be good or not good for you. But what I can say is that in the volumes you're talking about, you're moving a little thing at about this speed and it's putting down a pencil width worth of plastic. I don't notice much of a smell, and so the volume of the scent is small. Now, if you compare that to for example, laser cutters need like a dryer tube out the window or some filtration because they create an incredible amount of particulates. And with laser cutters, there's some materials you don't want to cut because you cut them, it gets you a carcinogen. But in the 3D printing community, this isn't really part of the conversation. And so to the best of my knowledge, it's a non-issue. Oh, and they put these things in libraries and schools. And so while I don't have any actual evidence, there's anecdotal evidence that says that it must be okay because otherwise you wouldn't see all of these things.
Can you, in your talk, you mentioned that there are some environmentally friendly filaments that are available to people. Can you talk about, are there specific requirements for a printer in order to be able to use those filaments? And I guess specifically, will the Prusa printers and the Prusa Mini specifically, will that print those filaments?
Yeah, absolutely. So every 3D printer can print PLA. The only really requirement is the heated beds because that lets you put more layers down. So like I printed my daughter a vase that's this tall, and without the printer's bed being heated, the layers will start not sticking together. But so PLA is probably the most printable thing. It's the beginner filament. It's the environmentally friendly one. It's the one that everyone comes with. There are flexible filaments. So if you want to print something that's sort of membraney or like a net, those have some different requirements. For me, those have been, so as a beginner, I'd be reluctant to target those just because they come with some heavier lifting in terms of the way that the filaments get fed in. But if that's an important thing, if you want to print flexible filaments, then you make that part of your choice. You buy a printer that has the way of feeding the filament in that supports that. And then the last thing is there are filaments that try to look like carbon fiber or try to look like wood. They come with particles in the plastic that will actually tear up the head. And so when you print with those, you tend to have to replace the print head. Whereas when you print just the screw on and the nozzle itself, when you print with non-abrasives, you essentially never have to replace the printer's nozzle.
Can you talk a little bit about your experience with dealing with undercuts and some of the other limitations that the printers have?
Sure, yep. So let me grab something here. All right, so it's a weird thing to do this kind of talk because you have a bunch of stuff in your notes and then you just start going off script and you forget them. So I'm glad someone brought that up. So when you print, so imagine you were trying to print a pyramid. And we'll just simplify it, make it 2 dimensions for now. Printing it like this is going to work. If you print it like this, it won't work because you have this little tiny point of contact on the bed. And so there are some shapes that have a geometry that you can't print. And so there's a couple of ways to do that. So if it's a mechanical part, oftentimes you can design around it. And so you can do overhangs. So, and they're, in fact, when people start really dialing in their 3D printers, they will get these prints from Thingiverse that'll show different degrees of angle. So you can say, okay, my printer will be able to do an overhang like this. The second thing is you can do supports. And so a support is, so imagine I wanted to print a Star Wars walker. And so obviously there's this gap underneath the legs. What it would do is it would put a very thin layer underneath, a sort of support structure that you snap off. The snap-offs aren't that aesthetically pleasing. And so one of the reasons you might do multiple, there's an upgrade to some printers, probably not the majority of them yet, that will let you do multiple filaments. And so I have it, but even for as long as I've had this printer, I've never installed it because I haven't yet had a need to. But if you do install one of those things, what it does is you can actually print with dissolvable filaments for the supports. So you can print anything and then just literally put it in water and the supports fall away.
Are there, you know, kind of getting to the community around 3D printing, are there any specific, you know, 3D printer YouTubers that you follow, or podcasts, or books, or other resources that you would point people to who want to accelerate their learning process in this?
Absolutely. So there's two. So I mentioned before Tom's 3D printing, and so he's probably the most well-known 3D printer, and he's got all these different series. So he's the person who will help you pick out one and who can help you get started. Then there's something called Cnc Kitchen. Cnc Kitchen is done by this German kid who is an engineer at heart. And so he answers the questions about how can I make the strongest thing? How can I make the most flexible thing? How can I make the most heat resistant? And so he does these really neat experiments. I'm a Patreon supporter of both of those. And then there is a third, and then there's some others that are sort of like kind of culture of 3D printing. Like, you know, there's subreddits, and like people post the little pictures that say always be extruding instead of always be closing. And so there's definitely the sort of the enthusiasm for this that you can find in places like Reddit. And so between that set of things, you should be able to, you know, find a home for your enthusiasm.
Besides Thingiverse, you know, are there other resources or other websites available to find objects that are ready-made and ready to be printed?
So Prusa has launched a Thingiverse competitor, and there are several others. Thingiverse was part of MakerBot. MakerBot was acquired by Stratasys, a local company. Frankly, it feels very neglected. I mentioned being between things. I had this crazy idea, since Stratasys is local, of going to them and saying, why don't you spin this off? I'll run it as a company, and let's breathe some life into it, because its search stinks. It just has all these things. Unfortunately, maybe it's like Craigslist. It's such a central thing that even though Craigslist kind of sucks, you still use it. Thingiverse kind of sucks, but you still use it. In terms of websites, you might check Hackaday. Hackaday has all sorts of things not related to this, but 3D printing is a big part of that as well, I think.
Are there places in the Twin Cities area where people can go and use 3D printers and test them out and sort of explore them without having to make the financial commitment to purchase them?
Can we go anywhere these days? No, but I'll try to answer more. I'll try to answer more.
I guess that's,
yeah. I'll answer it more reasonably.
That's fair, Dan. That's a fair.
Yeah.
Well, I guess mask. You could print a mask, I guess. And go.
There you go. So first of all, I would be glad to print things for people. Like, so I started a bullet journal recently, and one of the things is make connections with people. And so if people are interested in this, connect with me on LinkedIn, and I'll get, because I don't do any other social media, and I'm glad to help. That said, you can actually just 3D print online. So you can take these shapes and you can go to places and they'll ship you one. There are a number of makerspaces. Those makerspaces almost always have 3D printers, but obviously they want you to be a member. I am, and then the schools. I've bonded with my middle school, my kid's middle school's librarian, because she's always printing things, and I was talking to her about it, and they have this really neat thing. Kids can print anything they want, but they can't download it. So then it makes it a project. They have to learn it and so on. So you'll find it in lots of schools as well.
Can you talk a little bit about, like, what are some of the more interesting things people are doing with 3D printer technology? And would you mind sharing, I guess, what are some of the more, I guess, useful and fun things, interesting things that you personally have done with your printer?
Sure. I'm a big nerd, and so for me, almost all of these things are in support of some project I'm working on. So early on, I created, and it's in Thingiverse, a thing that lets you put a phone on the top of a camera. Put a phone on the top of a microscope or a telescope. And so I use that to take high res pictures of microscopic things and of the and of Jupiter and its moons. There are people who just are so so. I'm an engineer at heart. There are people who do incredible art pieces, things like 3D printed dresses. It comes off the printer, expands, and you can wear it. And so it's really, I was trying to think of if there's an analogy. So I was reading something recently where someone used the invention of the printing press to try to extrapolate and say, what does the internet give you? And so if you have this thing from a pen to a printing press to the internet, I think we went from bespoke blacksmith stuff to industrial to anyone can manufacture things. And so I look at it sort of in terms of it gives you all of these capabilities. It comes with some constraints, but it puts, it's basically what the 3D printer is to me is what a laptop is to me. It's a much more personally usable version of a mainframe than I could have had access to. So just, for me, it's just a door opener, but depending on what you're into, someone has done something clever with it, I'm sure. Terrible answer.
It's all good, Dan. So
you get what you pay for.
I do have a question here. It's sort of off topic a little bit, but somebody's asking, is there a CNC model or kit that you would recommend? Sort of, it's moving away from the additive manufacturing to more of a subtractive one, but.
So it depends on your application. So I'm sure the person asking this is not saying, I really wish I had a CNC to be able to mill PCB boards. But if you were, I would say the Bantam tool used to be called the other mill. There is a whole class of things. Shapeoko is one of which are roughly $1,000, sort of accurate, can do thin woods kind of things that are okay. But for me, none of them were good enough. And so in all cases, I'd rather use something off the shelf. Like I gave up on my own 3D printer because the Prusa is so good. And I haven't found something that matches that in the CNC world. So I'm building / have built my own. Yeah, so sorry, I don't have a very good answer for that.
How do you see the 3D printing technology changing over the coming years? I mean, are there big innovations coming that we should be watching out for? What's the new and interesting stuff that's happening in that space?
Yeah, so everyone probably is familiar with the hype cycle where everything is like, where you think something's going to take over the world, then you have this trough of despair, and then you climb out of it. So we're in the climbing out of it period of that. So the MakerBot was acquired by Stratasys for $400 million, and they put them into Home Depot. And the idea was that people are going to have these in their homes. And you could find these academic research things that said that 60% of the things that you had in your home could be 3D printed. And it didn't materialize. And so, so you got into the trough of despair. It turned out that the speed and the limitations didn't make it a sort of generic consumer device. It's not the Star Trek replicator. And so there's, I think, different possible futures. The one that I think is most interesting is when we sort of, and you see Adam Savage and some of the sort of widely known builders, where we bring this idea of people being able to create things back. So not everything comes from far away, and not everything comes in a way that's not digestible or repairable or take apartable. So when I look at where printing and all of these things go, I think it's in that world. I think we're due for a renaissance when it comes to actually building things. I actually took 6 months, a year off in the middle. So I bought that thing in 2016, and then I had that sort of point of disillusion. And when I came back, I thought, I wonder if things have moved on. I thought, like, maybe everything has changed. And it's really been Kaizen. So Kaizen is this idea that you make continuous improvements. It's not a revolutionary thing. And so the continuous improvements over the sort of year or two, well, the year I was away and the 3 or so 4 years that I've been at this have just generally made it more reliable. And so the linear, not revolutionary thing is that these things just get easier and easier to use. I think it's tough to be profound and predict disruptors, so I don't know what the disruptor is.
So I think we're down to 1 more minute here. I guess I have a personal question here. You've plugged the Prusa a few times as being a brand that you like. Are there any other brands, if I were to go out and consider buying a printer, are there other brands that you would, I guess, quote unquote, endorse or at least recommend that someone might look at as a viable option for a solid printer?
Well, the Ultimaker is good. It's very, very expensive. The Lulzbot was good, but they've kind of gone through some issues where I'm not sure they're a viable company anymore. They're trying to bring themselves back with this company in North Dakota. You see a lot of folks talking about the Ender printers. I don't have any personal experience with that, but it's more on the budget side of things. So I think those would be places to go. And then, more broadly, if you're interested in the laser cutter side of this world, frankly, I'm going to need beta people. And so if the idea of building things with frickin' lasers sounds good, reach out to me. And if not, well, hey, we're at the top of the hour, and I managed to get my plug in at the end.
What's the best way for people to reach out to you?
So Dan at unpossible.com. I don't really have a social media presence. I found it made me live my shadow life and not my real life.
Are you available on LinkedIn too?
Yeah, I'm on LinkedIn, but that's the easiest way probably.
Okay, thank you, Dan, and thank you to all the participants for showing up and for asking your questions. I hope this time was of value to you, and that I hope you all learned something. And I want to, I guess, thank the folks over at Minnestar again for putting this together. Thank you.
Thanks, everyone. Hope to be in contact with those of you who want to talk further. And thank you, Mike.